Hello, sir. Hello.
Yes, please.
Uh,
Okay, let me
I
check.
have sent business paper WhatsApp group.
Okay, let me check. Okay, let me share my screen. Okay, can you see my screen?
Yes, sir. Yes, sir.
Okay, so this one, estimating forest canopy cover and forest fragmentation mapping using Landsat satellite data. Okay.
Yes, sir.
Okay, so they are used at the forest canopy density model. Okay, FCD.
Yes, sir. Yes, sir.
By applying this model, it is easily determined that how much forest areas have been either deforested or degraded. And the FCD map has been designed by the weighted overlay analysis technique using ArcGIS. Okay. Forest canopy density using FCD model. Okay.
Yes, sir.
Okay, so do you want to follow this method or you want to apply for Google Earth Engine, mainly coding?
Yes, sir. Yes, sir. Yes, sir.
Okay. And there also make the weighted, assign the weighted value. So this type of things we can also apply. Okay, I will show you that one code for that. So okay, so this code basically we already, so this type of indices ndvi evi savi, then bsi, then si. So this type of index we already had, then
Yes, sir.
vsi, basically these are index. Okay, and further we calculate the
Yes, sir.
Landsat 578 with this type of things. Basically we take the collection for Landsat 2022 and 2000. Okay, and then we add the ASP method, assign the
Yes,
value.
sir.
Suppose for ndvi we assign the value 0.3, evi 0.2, 0.2, 0.1, 0.1, 0.1, total 100% or total 1 for ASP. Okay, after that
Yes, sir.
normalize the
Yes, sir.
band and apply the weighted. Okay, just we have normalized and weighted this type of band, but it provide you that ASP forest covers suitability. Okay, where is the high forest, where is the low forest, medium, based on this type of factor. Okay, based on this weight, ndvi evi savi or bsi or si or vsi, then we can also get. So this is the one way. In this time it also apply the ASP, basically this type of value. Further you can also apply the ASP and also determine for NDVI 0.3, AVI 0.2, you can also change it this type of weighted, it also possible. And finally we just simply normalize the band and apply the weight. And then we just create the layout about that.
Yes, sir.
Okay, suppose low, very low, medium, high, this type of map which we can got in your paper. Okay, so it also possible to create using also coding.
Okay, sir. Okay, sir.
Okay, so in this time here you can see they also make the class for NDVI very low. Basically they set the weight 5 4 3 2 1, then 5 4 3 2 1. Basically 5 is very high, then 4 is high, 3 is medium, 2 is low, 1 is very low. Also same as for, so this type of theme or this type of factor they assign. Okay, and apply this type of weighted, and then based on this weighted just apply the ASP. But in this case they apply the ASP using a tool. Okay, their tool name is that FCD model. Okay, FCD model basically forest canopy density model.
Yes, sir.
It's available, I think, also ArcGIS, this type of model, it's also possible to use it. But in this case we are apply here that Google Earth Engine. Okay, and then forest fragmentation. For the forest fragmentation also possible to use. They are also used at the fragmentation tool version 2.0. Okay, further also the forest fragment we also do it easily, no problem. Forest fragmentation is also possible to identify. And finally they are calculate the total canopy density. Basically you can see very low, low, medium, high and very high using the ASP. In this time this paper use the FCD model, but we try to apply in here coding. Okay, based on this weight, suppose 0.3 0.2 this type of weight, we try to identify the density, mainly forest cover suitability, mainly forest cover density, where is the high density, low density, medium, this type of things we also try to get from here. Okay, so let me, I think some problem in this
Okay, sir.
code, let me try to fix it and then check the result. Okay, so in this
Okay,
case
sir.
our analysis date, basically we try to check the result for 2000 2002 2022. Okay, this is the time period 2000 and
Okay, sir.
2022. Okay, so now, okay, so we take this, suppose let me check the study area. Suppose I take the for whole Gujarat area. Okay, let me add this layer, map.add layer, and call this study area, run it. Sorry, oh sorry, just copy and use it. So this is our study area. Okay, and now, okay, so this is study area. I want to suppose Landsat 8 and take this satellite imagery first. Okay, in this time this could also just make the, okay, it create the merge from Landsat 578. Okay, okay, it's not need, just we try to get this imagery. Suppose these things don't need, just I try to change it. Suppose I just take this satellite imagery image 2022. Okay, so now call this image collection from Landsat 8. Landsat 8, top of atmospheric reflectance we try to use. Just copy and paste here. So further we try to filter it. Just use here filter bounds with our study area, which is study area. Then filter date I take this 2020 1st January from year of 2020 December 31. This is the time period, and we choose the filter metadata. We choose suppose cloud cover less than, set the value for 1. Okay, so now all of indices we already calculated as a function. This function simply connect with our image collection. Just use at the map function and connect. Okay, so after connecting all of indices, we just okay, we are just create the median. Further, this thing just clip with our study area. Study area. Okay. Okay, so now after doing these things, we are just generate the image composite. Image composite is already done. It is stored in this variable. Just I copy and change it. Just paste here. So now we assign this suppose same weight we try to apply in here first. So now check the code and what problem. Okay, so it show that a is not a function. Which one? Oh sorry, add indices. This is the variable name. We are just connecting. Now run the code. Okay, it show a problem. This problem is that near available band name is that. Okay, 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 we also need to change it. So suppose near band, basically this is the near mainly B5 for near, red mainly B4, B4 red, and then what is the near mainly B5. What is the red mainly B4, then blue B3, then same as near B5, red B4, sorry B4. Okay, then or to change near B5, red B4, shortwave infrared one, it's B6, and blue it's B3. Okay, and same as near B5 SWI mainly B6, then BSI and DVI SI. So it already done. Okay, now run the code and check what happened. Okay, it's done. So now it find out this type of result. And it display the red, yellow, green. Okay, so let me stress and then check the result. Further, this thing we can download as a TIFF format. Okay, TIFF format, and then we also make
Yes, sir.
the mainly just go to the symbology. Then we simply choose the class. Okay, 5 class or
Yes,
4
sir. Yes,
class,
sir.
and also do it. So let me from here, suppose I want to add suppose 5 class. Just simply add the color, suppose red, yellow, then I put here so it's one suppose this type of color, then use suppose this type of color. And basically when you apply for the forest area, then it also get the more better result. Suppose, so now it show about the whole Gujarat, okay, but when you apply suppose only for the forest cover area, then you can easily find out this is the high density forest, this is the low density forest, this is the medium density forest, then you can easily identify. Okay, that was just stressing. Okay, now further apply. So now we find out this type of map. Okay. This type of map we find out. It's not only for the forest. So if I just suppose I want to apply this code for the study area, suppose mangrove forest in Bangladesh, I want to apply and then check what happened.
Yes, sir.
Suppose then you also get the more better result. Yeah, Sundarban mangrove forest. We try to apply. And now change it. Just a comment. And these things I want to add. And also focus on the center. Map dot center object. Object is study area. Zoom in and on the board. So now we find out this result for mangrove forest. Okay. And now we also apply for different types of color. Suppose red, I want to put this type of color, then put this type of color, then put this type of color. Or I put this type of color, just apply. Okay, then we try to apply it, suppose stressing 98%. Just apply. Okay. So now from this map we can easily identify. Okay, or you can just simply download it as a TIFF format and further just check the result. Okay, just simply go to the symbology and make the total 5 class. Further you also calculate the area. Okay, suppose basically for that low value, suppose you can say negative value indicating about that no forest. Okay, so it's non-forest area. Okay, then if I find out that high positive value indicating about that high dense forest. Okay, suppose you can simply, suppose you make the 5 class, just download this map and just apply the 5 class. You can find out that suppose negative value it is the non-forest, or low density you can also mention, then high, moderate, very high, high or very high. So just make this class, and further you can also create this type of map which you send me this paper like that, same paper. So this is the result for year of 2022. But when you work for the 2000, just simply change the image collection. You can see just simply change the image collection. It's the Landsat 8, just simply change it image collection 7, Landsat 7. Okay, and when you apply the Landsat 7, then you also need to change some band name, because Landsat 8 and Landsat 7 band is some difference. Okay, just simply check for the Landsat 7 what is the band name for near infrared, what is the band name for red for the Landsat 7, then also mention in here. Then you can also get this result for year of 2000. Okay, and now this is the result for 2022. And in this case you also modify this type of weighted value. So basically in this case we are just example we set this type of things. Okay, NDVI 0.3 and AVI 0.2. Okay, but if you want, you can also change it. So there's a lot of way for change this type of. You also take some paper. Okay, also mention this type of paper. Also use this type of weight. You can also use it the same weighted. Okay, just add some reference when you add this type of weighted, and then simply normalized this type of weighted value, and then we are just display this type of things. And from here you can easily download this data as a tip format. Okay, so this one is for your mainly forest density using the ASP method. So using this type of code we can easily get, based on this type of value we can easily get the result, where is the high density, low density, medium density, this type of things we can easily get it from here. Another thing is that you also forest fragmentation. Okay, so this is another topic. So I have to show you that how we can easily identify forest fragmentation. Okay, let me open my previous code. It's opening. Okay, vegetation fragmentation or forest fragmentation, same. Okay, so let me run the code. So okay, so basically in this case we are this code basically used for Sentinel to satellite imagery. So you can easily apply for Landsat, same process. Okay, just simply change the image collection. So now you can see basically forest fragmentation refers to the breaking up of continuous forested area into a smaller, okay, or it also say about that isolated pests due to the natural process or human activities such as deforestation, agriculture, or urban expansion. Okay, so we can easily use the remote sensing tool, and further we can easily identify. Okay, just a minute. So if you check it, this is the forest. Suppose this is the forest or vegetation. So this is the vegetation. So now we calculate the fragmentation. Okay, basically fragmentation refers to the breaking up of continuous forested areas into a smaller or isolated patch due to the different types of natural or human activities. So this is the forest or vegetation. So these things, if you check it for the fragmented passes, okay, so now it display the fragmented passes. Okay, so basically it show you that isolated pass or breaking up of continuous forested area into a smaller or isolated pass due to the natural process or human activities. Okay, so you can see, find out, okay, individual. So this is the one kind of pass fragment, this is the another fragment area, this is the another fragment area. Okay, this is the another fragment area, this color indicating about the another fragmentation area, this color indicating about the another fragmentation area. Okay, so this is the fragmented pass. Then if you want, you can also, you can see number of passes, how much fragmentation or how much isolated pass we find out for this study area. We find out the 2672 pass, fragmented pass we find out in here. Okay, so this is the fragmentation, mainly isolated group. So it create total 2672 672 passes it created. Okay, so how I can create, we can see first of all, this is the sentinel to image collection. Just we make the ndvi. After that we just apply the threshold value. Suppose I take that ndvi 0.3, greater than 0.3, Then identify fragmented passes. So we find out the 2672 fragmented passes, mainly isolated group for my forest area. So basically different types of region to increase this type of number due to the urbanization or deforestation or agriculture or urban expansion. We find out this number is very high. Okay, so then further we also calculated that page density. Okay, page density, also edge length. Okay, also edge density. So you also try to check some paper, then you also get about that different types of definition, this type of things. Okay, then fragmentation index. Okay, so when you can get the high value, when it can get the low value, so what is the meaning about that, this type of things you can also get it. So in this case, it just work for the Sentinel 2, but you can also change the image collection, and further you can also work with for the Landsat between this time period. Okay, suppose 2000 to 2000 and make for 2022. Okay, so I will send you this code. You also try to, okay, both of code I will send you. So you also try to add up this type of code for your forest area. Further
Yes,
face
sir.
any
Yes, sir.
problem, then I also guide you.
Yes, sir.
Okay,
Sir, how to calculate advanced vegetation index?
okay, advanced
Vegetation
vegetation
index.
index.
Sir, not there.
Okay, so okay, what's the formula?
Huh.
Okay, basically what's the equation? Okay, then send me that. I also try to add up at
Okay, sir.
advanced. Okay, you can send me the equation. I also add up the code and send you, no problem. For the advanced
Okay, sir. Okay.
vegetation index.
It is the main part, sir. My research work.
Okay, so send me the equation. I also try to add up and send you.
Okay, sir. Okay, okay.
Okay, thank you. Thank you.
Thank you, sir. Thank you so much. Please send me Google Pay
Okay, I will send you now.
details.
Okay, just a minute. I send you now.
Okay, sir. Okay.
Okay,
Thank you,
thank you.
sir.
Okay, have a good night. Bye.
Okay. Okay. Thank you, sir. Good night.